we'll be looking at topic number 8, trigonometry and geometry, and specifically that itself is broken down into other subdivisions. As my students are asking for particular notes on this area, let's go into it. To set up the basis for either one of them, trigonometry or geometry, just a quick revision. Remember, the types of angles are moving from 0 degrees up to, but not including the 90. Anything less than 90 degrees is an acute angle. Recall that when we speak about angles, it means how much is the turn of the two arms. So angles is actually a measure. And at the CSEC level, we are measuring in the units of degrees. When the angle increases a little further, it becomes a right angle or a quarter turn, or is also referred to as being perpendicular, meaning that it is exactly 90 degrees. And then we go even further. It goes past 90 degrees but doesn't come to the point of being a straight line. So anywhere in that second quadrant, it is known as an obtuse angle, meaning it is greater than 90 degrees, but at the same time, it is less than 180 degrees. And if it increases further to a full straight line, then let's recall that is exactly 180 degrees. And as we increase even further, anything more than 180 will be considered a reflex angle. And the reflex angle increases until we get a complete rotation, which will be a full circle of 360 degrees. And let's look at a little revision of the types of triangles. And we can subdivide them by side. And if we think about that, we have 3 equal sides in terms of length. Then it means we also have 3 equal angles. So equal sides is referred to as equilateral. And equal angles means that it's equiangular. So this is normally referred to, this sort of triangle, where all 3 sides are equal, all 3 angles are equal, as an equilateral triangle. And if we move from 3 sides being equal to 2 sides being equal, then that is an isosceles triangle, which means that there are 2 equal sides, in this case, the sloping sides to the left and right, and therefore there are 2 equal angles, which are the 2 angles at the base. And of course, these triangles can be rotated in a clockwise or anti-clockwise direction, and it still holds the same properties. So we spoke about triangles with 2 equal sides, triangle with 2 equal sides, and now if we have triangle with no equal sides, then there is no equal angle. Remember that the side is opposite of the angle that is related to. So if we have different length sides, we're going to have different angles. And as we related to triangles by side, we can also relate to them by angles. So we can consider an acute triangle where all 3 angles are less than 90 degrees, but they will of course add up to the total, which is 180 degrees. Or we can have a triangle where one of the angles is 90, which means that the other 2 angles will add up to 90 as well. So those will be considered to be complementary angles. So that is called a right angle triangle. Or where one of the angles is more than 90, then that's considered to be an obtuse triangle. So now we have trigonometry and geometry, and we can either subdivide it into trigonometry or geometry. For this video, upon the request of my students, we'll be looking specifically at geometry. And let's recall that geo speaks about the earth, and metry or metric speaks about measurement. So it really speaks about earth measurement. So geometry itself where it comes from that root definition, is a branch of mathematics concerned with questions of shapes, sizes, relative positions, figures, and properties of spaces, and so many more. So, for today's session, we'll be looking specifically at the idea of construction. So, we'll be looking at specifically geometric construction, and this should help support our students in terms of the 3 videos we have already posted with past paper solutions from 2009 until present. So when we speak of geometric construction and we're looking at the present syllabus, it shows that we have to be able to construct 5 particular angles. So let's look at it. The objectives are we must construct a 60 degrees, 30 degrees, and we're going to do that using the 0 degree and 60 degree line, 120 degrees using the 60 degree line, 90 degrees using the 60 and the 120 degrees, and a 45 degrees using 0 and 90. Now, there are many ways to solve each question or go about constructing angles. What I've found is that students get better at the topic when they keep using the same general method. So, if we look at constructing a 45 degree, it means they must know how to construct a 90, which means that they need to know how to construct a 60 and 120, right? So therefore, that helps to revise all the others. We can learn shorter methods for each individual angle, but then it will end up that students have to learn 5 different methods, when we can use one method and just extend it somewhat to move from one angle to the other. We also have to be able to construct a perpendicular bisector of a line, construct a perpendicular to a line from a point, and construction of parallel lines. So hopefully we'll be going through all of these things today. So one of the things that generally when we speak about questions like this, we would like students to first of all read the question and then draw a freehand sketch, a very small one, maybe taking about 20-30 seconds to do such, in the corner of the page, and making sure that it is following this general information that was given in the question. So when they see that, then they have a model to follow from. After they draw a freehand sketch, the next step will be always to go and construct a baseline. And when we draw our baseline, from there, we can now proceed to actually solving the particular construction. So let's look at the construction of the baseline. So let's assume that we have to make a baseline PQ of length 8 centimeters. And we're going to use this throughout, because as we looked at the steps, every question that we're doing, we start off with constructing a baseline. So first thing to do is draw a long baseline, longer than the 8 centimeters. And you'll see why just now. And now we can open our compass, put it onto a ruler, make sure it's 8 centimeters exactly in length, and then place the metal point, which in this case I have as being pink, on the left hand side, resting on that long baseline. And we're not putting it on the edge, we want to put it a little inside. And then we're going to take the pencil, whether it's mechanical or not, and scribe an arc from below that baseline. So we're drawing an arc that cuts the baseline, and that point will be labeled Q. So we've gotten half of it. And now we reverse the compass. So we place the point of the compass at Q now, the metal point. We put our pencil below the line, taking our time not to open or close the compass and change its length. And then do the same thing by constructing an arc. And when we scribe those arcs, we now have the length PQ being 8 centimeters. So one of the things we must always remember when we're talking about proper geometric constructions, as your teachers are well aware, that when we're showing where the points is on a particular construction, it is shown by two lines intersecting. So we're seeing the baseline in blue and this arc that was scribed in pink. So they cross at some T, and that point of intersection will be the exact point of P and then Q. If we had moved it so it starts on the end, then we will not be seeing a cross. It will be like a T. And we definitely don't want any of those. We want to have extras on either side. Now that we've finished constructing this, we leave all of those lines because that is our working. So that when the markers are there, they will be able to recognize these things are happening. Now that we've constructed the baseline, let's recall that if we're looking at the general idea of making angles, it is something that you've been doing a lot. Many students, even at the primary school, like to make patterns and so forth. And some of them have compasses that they carry to school. So let's make a pattern as such. So if we have the center there of a circle and we draw a circle around it, we can either use our compass or we could use a cover or something plastic, a plastic cover, and trace it and we get a circle. We can now from there, let's make a pattern, taking the same length, move the center of our circle or our compass onto one of the edges or anywhere around the circumference, and we can scribe an arc. And let's call that A and C. It's not necessary, but it's just easier for us to identify. So we're making the arc, and notice I didn't start exactly on the circumference. I start a little lower. So you get accustomed that when you're doing geometric construction, it is not art. It is a perfect way of identifying where points are. So we need to find exactly where A would be. So we need to see where they are crossing. And if we made one arc there, we can move it now where we rest the point at another part, and there we can get AE. Right? So we've just shifted the center of our arc there, and that means that we have a little pattern in here. We can shade if we want. So many students I see in standard 3 and 4 and so forth, they're doing this in primary school, so we're definitely at a higher level. We can see this. And we could scribe another arc by shifting our compass, the metal point, up on top, so that it passes through E, the center of the circle, and C. And if we do that, we can get another pattern, one on the right, and of course, one on the left. So what have we done? We've created a circular pattern that if we rotate it, it still remains the same. But greater than that, we have also taken the circle and cut it into 3 equal parts. Because if we think of the center of the circle and we draw a line from the center to A, to C, and to E, then we have split it exactly into 3/3. And remember that if an entire circle is 360 degrees and we divided it by 3, then we have gotten 120 degrees apart. We've just made that precise geometric construction. The key to this is if we're using a compass to make sure it does not change its length. And we can go on. We can make another one. Let's make a curve here where we rested our center of our compass or metal point at C and made a curve. It would pass through the center, and we'll just call those, just for reference points, B and D. We can now rest our metal point of our compass at A, and when we scribe an arc, scribe meaning to cut an arc, then it will pass through B, the center, and some point F. So that means we have another pattern. So if we're thinking of petals, we have 3 green ones, we have a purple one, and now if we rest our metal point at E, then we're able to see we have created 2 more petals, one on the top right at D, and one on the left at F. So what have we actually done? We've created a beautiful pattern that you can color and so forth, and something that you've been practicing, some of your friends or so forth would have been doing it since primary. And not just that, but we've also taken this circle and subdivided it into how many parts? A to B, that's 1, B to C, 2, C to D, 3, D to E, 4, E to F, 5, and F back to A, 6. So we've taken the circle and split it into 6 parts. And if we think about that, that means that we have 360 degrees divided by 6 will give us 60 degrees. So from A to B, that's 60 degrees. So if we draw a line through the center to A and through the center to B, that is 60 degrees, and it's repeated 6 times. Now that we look at that, we can think about the idea of having a protractor, because that is actually what we're doing. So if we come up with the idea of resting our protractor across here, where the center is at the center of the circle, then one of the things to recognize is, remember, our protractor measures the turn. So if we're thinking of our horizontal line starting from the center of the circle going to the left or going to the right, and then turning, let's take the right first, from the center of the circle O going through C, and we consider that to be 0 degrees. By the time we go up to D is 60, and then we move to E 120, and then to F 180, because we said from one petal to another is 60 degrees. So we have 60 and 60 120 and 60 180. Or if you look at your protractor, you'll see that the measure goes in both directions. So we could have started on the left-hand side, make that 0, and then we go up at E is 60, and we turn to the next angle, 120, and the last petal, 180. And basically what we're saying in geometric construction is we're actually doing this so precisely, it is like making a protractor. Whether we have a semicircular protractor or one which a complete circle, it does the same ideas. So let's now go on. We're going to combine this skill of drawing a baseline, which we've practiced just now, and the idea of making angles here to go on and solve the rest of the topic. Everything is based on this. So let's construct an angle of 60 degrees. And of course, the first thing to do is draw a long baseline and go through that route there, which includes constructing the line by resting it at one point, scribing an arc, and that of course will give us Q. Rest it, spin around the compass, rest it at Q, scribe an arc, and that will give us P. So that has given our baseline. And now we would like to think about the idea of that picture just now, where the center of the circle was at P, because if you notice at the heading, we're constructing an angle of 60 degrees at P. So think of the center of the circle just now at P, and if we're going to Q, that would be 0 degrees. So we open our compass to any length, it doesn't matter, whatever we're comfortable with. Or if you're a little unsure about the compass, you can actually use a plastic cover, as long as we know where the circular plastic cover, and we know exactly where the center of that cover is. We rest it over P, and we can use that to scribe our arc, right? So we can rest it there. I'm using a compass, you can use whichever. And what we've noticed is at that point, that was our 0 degrees that we just wrote. And we're forming that protractor there, the semi-protractor from 0 going up to 60, 120 and coming across to 180. So you can make that arc that we made as long as you want and come straight across and to the point where it hits this baseline to the left of P. We would have to have a longer baseline, of course. Now that we know that, we're almost finished. So now we, just as what we did previously, we can take up our compass, move the metal point to the point where it is at a petal, which in this case is 0 degrees, and from there, scribe an arc, and that would give us our second petal, which was 60 degrees away. Therefore, we have just drawn an arc, cutting the main arc with the point of the compass on 0 degrees. And now what do? We complete it by drawing a line passing through P and the intersection. And that says that we've just constructed a 60-degree angle at P. What you should do, students, would be take the same steps, follow the format, And remember, we're connecting to what we did before. We're connecting to doing a baseline, connecting to drawing those petals, and do the same question, but construct a 60-degree angle at Q. So that would be your homework. Let's go on to constructing another angle. We did 60 degrees. So look at the heading. We can construct a 30-degree angle at P again. And how do we do that? We're going to use the 0 degrees, which we just got, that line, and the 60-degree line, which we just got. So we're building on that knowledge that we have, which is knowing how to construct a baseline and, of course, how to construct a 60 degree. Using those skills, we're going to be able to now construct a 30. So we're going through the motions here of scribing our arcs at Q and at P and having those there, right? Now we've set up the baseline. We're going to do the same thing again. We're going to make a 60 degree. So we're scribing an arc, which was 0, and then we scribe another arc, which is 60. And if we think about the idea of that being our main arc along the edge of our protractor, then where will 30 be? 30 has to be in the middle of 0 and 60. So when we're finding the middle of 2 points, we're saying that we're bisecting it. We're cutting it in half. So how do we do that? Look in purple heading up on top as our little reminder. We're using the 0 degree line. So look, we took the 0 and instead of making a short arc, we made a longer arc. And why is that? Because we know the 30 degree is going to lie halfway between 0 and 60. Now, there are other ways to do this as well. We could have drawn a straight line from 0 to 60 using our ruler, and in the middle of the line, put a mark, and then draw a line from P through that mark, and that will give us it as well. So there are different ways. But because the topic is asking that students build the skill, and they're looking for that in the assessment, that they want to see the skill of using your compass to construct this 30. Compass and, of course, your ruler. Using a protractor and putting a point there and just drawing a line through it is not constructing. So we're following the steps using 0. We just use 0. And now we're going to use 60. So we're going to rest our point at 60 on that main arc and scribe an arc. So we use it as 0, got the arc going, the horizontal arc going to the right. And then we rest it at 60 and we cut another arc. And we can now draw the line passing through 30 degrees. And that is our construction of the 30-degree angle. As I said, you as students want to practice this again, do over this for yourself. And if you want, try it on the right-hand side at Q. So the line will eventually face coming up to the top left. And of course, just as the 60, when you're finished, you're going to take your protractor and check it to see that it's exactly 60 degrees and not 59 or 58. Similarly with the 30 degree, we're double checking it using our protractor, using our ruler to measure to make sure it's 8 centimeters. Or we can also use our set squares. Remember, we have 2 set squares in our geometry set. One will be the set squares, meaning the 2 triangles, one of them being a 45-degree set square. So it's a right angle triangle with 2 45 degrees. So a nice isosceles triangle as well. And the other set square has a 30-60 angles on it. So we can use that 60-degree angle and check just now where the 60 lies. And we can use the 30-degree side of it to check the angle as well. Not just a protractor to check angles. So we've constructed a baseline. We've constructed 60 degrees. We've constructed 30 degrees. Let's move on now. We want to be able to build on that knowledge. We want to construct a 120 degrees angle. And we're doing it at P. We're going to use the same example throughout. And we're using the 60 degrees. So of course, we go through the first steps as usual. We construct our baseline. It could be any length. I am just using a standard, PQ being 8 centimeters. PQ could have been 6.2 centimeters. It could have been named AB, but you get the general hang of it. So now we've gone through that basic step. The next thing, for every single angle that we're constructing, we're going to try to build that protractor. So we're going to rest it at P, right? And of course, make this long arc. And we know that's 0. We could cut it at 60, right? So we have those two. That's every one of the angles. We're going through those same steps. So as we practice the other angles, we get better at making the baseline. We get better at making the 60 degree. So now that we have there, how do we get a 120? Well, there are a couple of ways. One way is using the 60, because I'm trying to build on our knowledge from before. So what we can do is, one way to do it is we could have completed that semicircle, go to the point of 180 degrees, which will be on the left of P, so we'd have to have a longer baseline, and then cut an arc from the 180 to indicate where 120 is. So it'd be happening on the left side. We're doing on the right side, we're going from 0 to 60. That's one petal, and if we want to go to the other petal, which is another 60, that means 120. Then all we need to do is draw an arc where we're resting our compass on the 60-degree point and scribing an arc. So we've moved from the petal which was horizontal at P being 0 degrees to one up at 60 to another one, which gives us our line that we're drawing through, which is 120 degrees. So it's good to put that arc around the 120 degrees at P, so it indicates what the value of that angle is. So we've constructed baseline, we've constructed 60 degrees, 30 degrees, 120 degrees. And we're going on to 90 degrees. And just like all the others, there are many different ways to construct a 90. But I'm still using the same skills that we had before, which was starting with a baseline and going forth. So it helps us to practice those skills. I personally believe that my students are stressed when they have to learn 5 different methods for the 5 different angles to construct. I prefer building knowledge on what we already know. So we take the 60 and we keep adding to that, using the same skill over and over. So just as we did our baseline, what do we do now? Draw the semicircle here, up however long you want. Start at 0, construct 60. See, that's the same things we're doing all the time. And then we want to construct a 120. And why we're making that arc, it could be short, but why we're making the arc long is because we recognize that we want to construct a 90 degrees or make a perpendicular line at P. If it's 90 degrees and you think about your semicircle, it has to be somewhere between 60 and 120. And we used this skill before. We bisected 0 and 60 to get 30. So we can bisect 60 and 120, and that will give us 90. Notice our hint up on top in purple, using the 60-degree line, we've just drawn an arc, and now using the 120-degree line, we're resting our compass, and we're cutting an arc. So what happens now? We're now able to draw the 90-degree line, passing through P and through the intersection. Make sure you're precise when you're drawing this line. It must go through directly where P is, meaning where the two lines intersect, and directly where the two arcs intersect up on top. You draw a perfectly straight line, and then you can use one of your set squares to check that it's 90, or you can rest your protractor there and double check it's 90 degrees as well. Construction of 45-degree angle at P using 0 degrees and 90 degrees. So technically what we're looking for is the direct middle between those two angles. So we can say that is called bisecting the two angles. So let's look at the steps. First of all, we start with constructing the baseline PQ, which we've done over and over again. So we should be clear on this, that we're putting our compass not at the end, but within it, so that we can see clear intersections of two lines to identify P and Q. And after that, we would like to make the normal 90 degrees. So we start off by drawing our main arc, our semicircle, which looks like a protractor. That's 0. We cut 60 degrees, and then without moving the distance, we cut 120 and 90, and we draw our line. So that reminds us how to do our 90 degrees. We went through 0 degrees, 60 degrees, and 120. And on that semicircle, the same main semicircle, we have the 90-degree arc. Now, what are we going to do? We're going to use the 0 degrees and the 90 degrees and bisect that. Find the exact middle, and that will be 45. So the 0 degree mark, we already scribed an arc which was 60 degrees, but we made the arc a little long. And why is that? Because we recognize that 45 degrees lies between 0 and 60. So we have already done this 0 part by scribing that arc. We now rest our compass on the 90 and then cut an arc. So we've just used the 0 degree and the 90 degree, and where they intersect, that will be, let's draw a line straight through it, make sure our line is accurate, and that is 45 degrees. So we've completed all 5 angles: 0 degree, the 60 degree, 30 degree, 45 degree, 90, and 120. So now let's look at the 3 other skills that are normally required. The first one is to construct a perpendicular bisector. What does that mean? And we could start off by drawing the baseline here, of course, and drawing a line which is a perpendicular bisector. Bisector means we're going to cut it in 2 equal parts. So we're going to find the exact middle of PQ, and we're going to draw a line. But that line is not any straight line. It's a line which will be at 90 degrees or perpendicular to PQ. So there are quite a few ways to do this as well. One of the ways, after we have opened our compass to 8 centimeters and cut the arcs, we can now keep it at that value or shrink it a little bit. The only factor in this is that we must make sure that our compass is more than halfway, more than 4 centimeters. So let's construct our arc from PQ. Let's go from Q, where our compass, it doesn't matter what it is more than 4 centimeters. And without changing the length of our compass. And in each one of these constructions, we keep reiterating, keep emphasizing, we are not to change the length of the compass. So if we made that arc from Q, we keep the compass the same length, and then we come at P and we do the same. So what we have is an intersection of P and Q, the arcs above the line and below the line. And now all we have to do is draw a line straight through them, and that cuts PQ exactly in half and forms a 90 degree between that line and the PQ line. So it's called a perpendicular bisector. So we're able to take any line and do this. My suggestion for practice would be take an angle at a slope, sloping up to the right, do the same thing as your baseline being that way, and find A and B or P and Q, any length, and try and construct the perpendicular bisector to that. And then think of it as a triangle where we have 3 sides are sloping in different directions. We did the base, we did the one sloping up to the right, and if we take the other side, practice it there as well. And that way we get a handle of it, because we're not too sure when we think of assessment and understanding concepts that it will be a baseline that we have to get the perpendicular bisector off. It could be any one of the sides. And now let's think of the next skill, where construction of a perpendicular to a line. So let's now construct our baseline, and we'll see from there, following the same formal steps, we go a little in, not on the edge, and we rest our compass and cut our lines, and we get Q, and we'll get P accordingly to whatever lengths you want. Doesn't matter. And then now that we have PQ, let's imagine we have a point R, and from R, we're gonna just draw a radius. Now, one of the things in it, we open our compass to any length, it doesn't matter, and cut an arc where we're cutting or scribing an arc, and it intersects the baseline, the line that we want to draw the perpendicular to. Let's call it the points of intersection are at 1 and 2. From there, we move our compass to where 1 is and scribe an arc, and then we're going to move it to 2, and we draw an arc below the baseline with the point of the compass on 2. So we're now able to drop a line from the from the point passing through the points of intersection. So what does that give us? That gives us a line which is at 90 degrees to the baseline, but it's not necessarily at the middle of the line. Previously, the skill we did was to do that for the middle of the line, bisecting the line. We can imagine this to be, we have 3 points P, Q, and R, of which are the corners of a triangle. And if we have the baseline PQ and we would like to get the perpendicular height, because maybe we want to calculate the area of the triangle, which is a half base times height, then from that highest point R, we need to drop a line directly down, which will be at 90 degrees to the base. So this is the skill required for that. And for the third skill, we would like to be able to construct parallel lines. So let's use the idea of constructing a parallel line 5.5 centimeters away. So we'll construct a baseline. And if we have our baseline here where we've done P and Q as usual, and we want to construct one that's 5.5 centimeters away, there are a couple different ways. We can use our two set squares and just rest them and slide them along the surface, and that will work. Another way to do it, because there's so many ways to do these. I'm just trying to use our compass here. Then we open our compass to 5.5 centimeters and just draw an arc. Remember, our metal point would be on P, and all we're doing is just drawing an arc from P. We can do the same thing at Q, where we rest our point there, and we draw an arc as well. And all we do now is draw a tangent to both lines. So we line up our ruler and draw a line straight across, and that distance away is 5.5 centimeters. So we've constructed parallel lines, and this will be helpful for us if we have to make a rectangle or parallelogram, right, where the opposite sides are in the same direction, meaning they're parallel. And this is the skill that we require. So what are the general things that we want to be able to do in this geometric construction at the CSEC level? One would be to construct a triangle given the information of the lengths of all three sides. The second one would be if we have to do the triangle, but they're giving us two sides and the internal angle between the two sides, or they're giving us two sides and one angle. So they're always giving us three pieces of information for us to be able to construct the triangle. We're given one side and two angles accordingly. So we have four different situations here. So we're going to do a question for each of those stages. So imagine we're constructing a triangle given all three sides. So let's construct a triangle PQR, where PQ is 8 centimeters, PR is 6 centimeters, and QR is 5 centimeters. And recall, the first thing we do when we get our problem is that we should encourage our students, we should be drawing a little sketch of what this looks like. You can put any one of the sides at the base. I choose to pick the longest side, but it doesn't really matter. So in this question, the longest side is PQ. So that follows our same practice that we've been doing all the time. And if you think of a sketch, we don't have any angles to construct, but we know the length of the lines. So if we think about where the lengths of the lines are, from P, there is some point R, which is 6 centimeters away. From Q, there is some point R, which is 5 centimeters away. And what we want to do is find that point R, and then we'll be able to connect all three, and that will give us our triangle. So how are we able to tell where R lies? Well, at the idea of P, we open our compass to 6 centimeters and scribe an arc. Now we could have scribed the arc above the line as we did, or we could have done it below the line. Both of them will give us correct answers. So there are multiple solutions here. And just as we know P and any point on that line is 6 centimeters away, that means R is somewhere along that arc. We could have made the arc much bigger as well. And from Q, we do the same thing, but our compass will be opened 5 centimeters. So if we open the compass 5 centimeters, right, now we have our point of intersection. Right, so just as the first arc, anywhere along that arc, it was 6 centimeters away from P. The second arc, anywhere along that line, it's 5 centimeters away from Q. Then by the idea of simultaneous, meaning that two sets of things are happening at the same time, which point is it that it is 6 centimeters from P and 5 centimeters from Q? It will be the point of intersection. So now we just complete the triangle. And we connect the dots, and we know that is R. One is 5, one is 6. And of course, we know our base is 8. So that's the way to construct a triangle if we were given the lengths of all three sides. Now let's look at the other version. If we have two sides and an internal angle. So now let's look at the question. Construct a triangle PQR where PQ is equal to 8 centimeters, PR is 7 centimeters. So I know the lengths of the two sides. And angle QPR is 60 degrees. Angle QPR means we're going from Q to P and then P to R. And that internal angle there, remember an angle is a measure of the turn. So if we want to shortcut the explanation, we will say the angle is at the middle letter, which is P. So at P, the angle is 60 degrees. So we have two lengths, 8 centimeters, 7 centimeters, and 60-degree angle to make. So let's construct these. Of course, we start with our base. We know PQ, in this case, is 8 centimeters, so we go through the same format again. And if you notice, hopefully you see the repetition of how we're using the same skill over and over and building on that skill. Right? What we're doing is scaffolding. So now that we have PQ, what do we know? We know the angle at P is 60 degrees. And we've done that before. So we could construct a 60-degree line, open the compass to any length, doesn't matter, don't change it now. Draw your main arc, draw your curve, and then your line through it, 60 degrees. Practicing this over and over will make us very adept at this skill. So we know a couple things. We know our baseline PQ, and we know P, and that black line that we drew upwards, sloping at 60 degrees, right? Somewhere along there lies the point R. And because QPR, that angle is 60 degrees. So we know R lies somewhere along that line, and we know one other thing. PR, the distance from there is 7 centimeters. So we don't use our ruler to measure it and mark it off. We want to see in geometric construction, we want to see construction. So we want curves or arcs. So open our compass to 7 centimeters, make sure it's precisely that, and then we construct it by resting our compass at P and scribing that blue arc. I'm using different colors, hopefully, so you can see the differences in what's happening. And knowing that, we know anywhere along that blue arc from P is 7 centimeters. So where are the two things happening? Where is it 7 centimeters away and maintaining an angle of 60 degrees? Where those two things intersect, right? So we'll complete the triangle and label accordingly. So we have two angles, we have two sides, 8 centimeters and 7 centimeters, and we have the internal angle of 60 degrees. Let's now look at the other situation. Instead of having two sides, right? Let's now look at two sides and an angle, but the angle is not an internal angle. So let's construct triangle PQR, where PQ is the base, 8 centimeters again, QR is 8 centimeters as well, and angle QPR is 45 degrees. So let's do the base, and then you'll pick it up. Hopefully you made your sketch already, and you follow the format. So we go along, we form PQ, 8 centimeters. And something else to note, QR is also 8 centimeters. So we have a triangle in which two sides have the same lengths. So that means it could either be one of two different types of triangles. Either it's an isosceles or it's an equilateral. So we'll have to figure out what's happening to the third side, then we'll know which one of those it is. So we got PQ is equal to 8 centimeters. And what we know is the angle is 45 degrees at P. So let's construct at 45, making our main arc. Let's identify where 0 is. To remember, this is our 60 degree. And from our 60, we can cut. We get our 120. And we cut at 120. We'll be able to get our 90. So we use those two. And we have 0, and let's cut from 90. And that will give us 45 degrees. So we know that angle QPR is 45 degrees. So from Q to P, that's our baseline, and P going up along that black line, somewhere along there is R, which is 45 degrees. And we also know that QR is 8 centimeters. So in some of these questions, you could get two different triangles above as well, which both will work according to the information given. So we now open our compass to 8 centimeters and draw an arc. And where does it intersect? It actually intersected at 2 points. It intersected at P, because P is 8 centimeters from Q along the black line and then intersected up on top. So now we could complete the triangle by drawing that line up there and showing where R is. So what do we recognize here? That this has two equal sides, so it's an isosceles triangle, and the angle is 45 degrees at P, and therefore the angle at R is also 45, which means the angle at Q is 90 degrees. So we made a right angle triangle, which was also an isosceles triangle. Now let's look at the next situation. We're given two sides. We did three sides only. Then we were given two sides and an internal angle. We're given two sides and another angle. And now we're going to be looking at one side and two angles. So let's draw a sketch where we look at the triangle PQR, where the base is 8 centimeters. That's PQ. And the angle QPR, which means the angle at P, is 30 degrees. And the angle PQR, meaning the angle at the middle letter Q, is 60 degrees. So let's construct our baseline as usual. And when we do such, right, we'll be able to get our baseline, our one side that was given. And we're recognizing this, and this should be following what happens in our mini sketch that we did. We now have to look at what next after this PQ, which angle we're going to make. So we could start at either one. Right? Let's look at the angle at P, which is 30 degrees. So we need to make a 30 degrees. How do we do that? We make our main arc at 0, and that's 60, and we use 0 and 60 and bisect it. So we're drawing a line through it. So that is 30 degrees. So what information have we put up already? We have put up the baseline, PQ. We've constructed that. And we've constructed a line where somewhere along that black line lies R. And how do we know that? We know that the angle QPR, which we constructed, is 30 degrees. But we just don't know which part along that line R lies. So now we go and look at the other piece of information. PQR, the angle at Q is 60 degrees. So it's an angle starting, you're at Q, that's your turning point. You're facing P, so that's your baseline, and you're turning clockwise 60 degrees. So let's go rest our compass and go through the same format. We draw an arc, we have it in a different color so you can recognize it, and we cut the 60 degrees. And now we've completed it. So we're able to say the angle at P is 30 degrees, angle QPR, the angle at Q or PQR is 60 degrees, and our baseline is 8 centimeters. So we're able to construct a triangle given one side and the two angles. Now, just to recall that we've done videos on all of these. We've started solutions from 2009, that was our earliest year, until the present. So we have 3 videos you can look at, covering the first video covering the past paper questions on this particular topic for the first 5 years from May 2009, 10, 11, 12, and 13. That's one video. The next video will be from 14, 15, 16, 17, 18. The third video is from 19 onwards. You can follow after doing this, practice it some more, and then you'll have more than 10 different questions to practice on this topic. Okay, goodbye.